We are going to start today with your bell ringer, which is practice over the last concept that we touched on in the notes yesterday. So it's very similar to the problem that was just on the screen, but you were asked to find out how fast a truck needs to travel to stay underneath an airplane that's moving 105 kilometers per hour at an angle of 25 degrees to the ground. So let's start by drawing our triangle. Okay, so we have the ground here, and we know that the angle that the airplane is flying at is 25 degrees, and we know that they are flying at a speed of 105 kilometers per hour. So the way to solve for this problem is to use sine or cosine to break this down into its components. So we don't need the vertical one, which would be opposite over hypotenuse, so that would be our sine. What we need is the adjacent leg that's running here, which is the adjacent leg, which means we are going to be using cosine. Okay, so your equation should come out to, so this is our, we're just going to call it, I don't know, let's call it v, since it's a velocity, right? Okay, so v is going to be equal to cosine of 25 times 105 kilometers per hour. That is an S, not an H. Okay, so if you do that calculation, if you do the cosine of 25, and then you multiply that by 105, you should come out with a number that is 95.1623 whatever, and we need how many significant figures? Any idea? Two. So we should just be at 95 kilometers per hour. There's your answer. All right. With that out of the way, we can hop back into the notes. Now we're going to talk about adding vectors that are not perpendicular. So far, all the vectors that we've been adding have been at right angles to each other, which has made the triangles right, which has made it very easy to do this addition. But we know that things don't always move at right angles to each other, unfortunately. It would be much easier mathematically if they did, but they don't. So when vectors that are being added are not perpendicular, you can't initially start off by using Pythagorean theorem and tangent function to solve for their resultant, because they're not at a right angle to each other, so Pythagorean theorem doesn't work, and those types of things. So instead, you have to start by resolving each vector into their horizontal and vertical components, which is what we just did with sine and cosine. So you resolve them into their horizontal and vertical components. Then you sum the horizontal and vertical components for each vector to get the horizontal and vertical components for the resultant vector. And then when you have those, then you can use Pythagorean theorem and tangent function to solve for the resultant. So it just makes it a few more steps. A nice picture of this, okay? So let's say you have a vector moving this direction, and then you have another vector that goes this direction-ish, okay? So they're not at right angles to each other, and we know that this right here would be our resultant, but we can't use Pythagorean theorem to solve for it. So instead, we go ahead and find this vector, and this vector, and then this vector, and this vector for the other ones. And then when you sum them together, what you'll wind up with is you'll have this summed and this. So if you add up the horizontal and vertical components for both of these two vectors, you'll wind up with these two down here, which you can then use with the Pythagorean theorem to solve for this one in the center. Don't worry, we are going to practice it. Here's our example. We have a hiker, and they walk 27.0 kilometers from their base camp at an angle of 35 degrees north of east. Then on the next day, they walk 41 kilometers in a direction that's 65 degrees north of east, and they discover a forest ranger's tower. Find the magnitude and direction of the resultant displacement between the base camp where they start and the tower where they end. If we were going to set that up, it would look a little something like this. Okay? Notice that you have 3 graphs this time, okay? That's because I started you out, the very first graph there, the bigger of the 3, is an image that shows you where the base camp is, where they walked, okay? So we have that initial angle of 35 degrees north of east, and then here we have the angle of 65 degrees north of east that they walk north, okay? And we know the length of this and we know the length of that. What we are trying to solve for is this right here, this resultant, okay? In order to do that, we need to break each piece up into its horizontal and vertical components. So that's what the other 2 drawings are. The top drawing is from base camp to the first night's stay, that trip, and then we can use this drawing to solve for the horizontal and vertical components. Then the bottom drawing, the bottom graph there, is the second day's walk from their overnight spot to the ranger's tower, and we solve for the horizontal and vertical components of that. And if we add them up together, we'll get the horizontal and vertical components of the resultant. See, if you add this distance plus this distance, that gets you the horizontal component. And if you add this distance plus this distance, that gets you your vertical component. So then you'll have a nice right triangle to solve for this resultant from. Okay? We're going to try it. So start small. Start by picking one of the 2 smaller graphs and solving using sine and cosine for the horizontal and vertical components of it. And then we'll move on to the next step. Okay, so we'll start with the first day's travel. Okay, you can solve, so the angle, which I'm going to try drawing on this. Maybe in a different color. Okay. This angle right here is that 35 degrees south of east that they mentioned, okay? So that's our angle. So the one that we would use sine for is the opposite, so x or delta y. And the one we would use cosine for is the adjacent one, which is your delta x, okay? So if you solve for this, delta x1 should come out to be 22 kilometers. And delta y1 should come out to be negative 15 kilometers. Because remember, we are going down in the coordinate system, so this is a negative number here. Okay? Then, if you are solving on day 2, you're still using cosine for delta x because it happens to be adjacent to the angle. That won't always be the case, so always double check. But you are indeed still using cosine, and it should come out to be roughly 17 kilometers. And then the delta y should come out to be 37 kilometers. So now what we want to do is come up with our total delta y and our total delta x. So if we're summing those up, then we should wind up with a delta x of 39 kilometers and a delta y of 22 kilometers because we have that negative in there. So that's going to affect things. If you forget to make something negative that is negative, then okay. All right, now we're ready to solve the rest of this. And to do that, let's draw our actual triangle here that we're solving for. So we have this resultant, okay, and what we just solved for were these components right here. And we said that our delta x was 39 kilometers and that our delta y was 22 kilometers. Okay, and we know this is a 90-degree angle, so now we should be able to use, and we'll say that this is our distance here, so we should be able to use Pythagorean theorem to solve for the magnitude of d, and then to solve for theta, we will need to use the tangent function. Okay, so go ahead and try and solve those, and then we'll come back together. All right, so if we run this, what we should do is do 39 kilometers squared plus 22 kilometers squared, and then we'll square root the entirety of that to come up with our magnitude, which should come out to 45 kilometers. Okay. And then we will solve for theta using the inverse of tangent of 22, the opposite, over 39, the adjacent. And that should come out to 29 degrees. And this, we look at the drawing that we made earlier of the resultant to know that that is north of east. So if we have to look at this drawing that we did earlier, so this one over here, right? And our resultant vector here is north of east.
How do we know it's actually north though?
Because they told you in the problem, they said that first they traveled south of east, right? So our initial line goes here. So that's saying this must be east and this direction is south. And then the other angle was north of east and it's up of this direction. So that's how you know. Although usually they will, when you set your coordinate system up, that's why we talked about at the beginning about when you're setting up a coordinate system, you should indicate which direction is east, which direction is north. And if we were looking at this problem, that the way they worked it in the book, they talked about that, saying let's set the x-axis as east, let's set the y-axis as north, and roll from there. All right, that's all the notes that I have for you guys from this section. Okay, your homework is going to be in your textbook. There are problems 1 through 4 on page 94.